So welcome everybody. I'm looking forward to talking to you for the next half hour or so about some of the challenges of assuring, and I use this word intentionally, assuring the future of software engineering and artificial intelligence engineering. So I'm going to start out with where we left off with Anita and Forrest and Paul earlier, mentioning the study, the national agenda study we did a couple years ago. In November 2021, and that date is important, we released the study. As Anita said, we've been doing it for a while. I won't go into much detail on all the different parts of the study, but in essence, there were sort of two different focal points: the development paradigms and advances needed there, and the advances needed in architectural paradigms. What I want to call your attention to, however, is the time frame, which was 10 to 15 years. That was what we thought was a good time frame. And when we were doing the study, people said, you really got to think outside the box. Don't just think the next couple of years down the road. So, of course, one of the things we realized was that within 10 to 15 years, it's very likely to be the case that we'll have software pipelines that are involving humans and AI working together as trusted collaborators to build systems based on intent rather than manually writing everything by hand the way that we do today, or by using some automation. And I remember thinking at the time, boy, that's pretty ambitious. 10 to 15 years, I'll probably be retired by that point, so I won't be responsible for all the chaos that's going to happen. And then, of course, what happens, lo and behold, exactly 1 year after we put the study out, ChatGPT escapes from the lab. And all of a sudden, all these 10 to 15-year horizons start to look quite a bit different. And for those of you who have not been frozen in carbonite the past 6 months or so, generative AI is really about creating models and systems that are able to synthesize new content, original content, maybe using quotes, original. And that's, of course, taking the world by storm. Now, when this happened, many of us, myself included, were very excited. But there were also a lot of people who had decided the end of the world was at hand. If you've seen the movie Anchorman with Ron Burgundy, you know his famous quote, "Boy, that escalated quickly." Now, I'm not here to opine on whether it's the end of humanity as we know it, but I will point out that if it is the end of humanity as we know it, some of our job is going to be a lot easier because we don't have to think 10 to 15 years out for our roadmaps anymore. Now, let's assume for the sake of argument that we're not going to die, and that we got to think about what's going to come down the pike. So what I'd like to do in the time that I have here today is talk a little bit about what may be the impact of generative AI, and more generally advances in AI, on some of the study findings that we have. Now, again, there's 6 areas. In the interest of time, I'm just going to focus on 2 of them, and the 2 I'm going to focus on are kind of obvious. They're the ones that are about AI-augmented software development, as well as engineering of AI-enabled systems. Now, there's a bunch of other things. We'll touch briefly upon them because they relate to some of these topics as well. If you want to see a little bit of our thinking about how this is affecting the other areas, we have a blog posting on the SAI blog that came out a couple weeks ago that starts down the path of thinking this through. But I'm sure we're going to do a lot more work on these areas and continue to propagate that in conjunction with all of you and others. So let's first talk about some of the impact of generative AI on AI-augmented software development. So for those of you who grew up with 1970s sports, you probably remember Dr. J. He was the Philadelphia 76er, I think he was a guard, who was famous for dunks. And they said, "Dr. J, why do you like dunks so much?" And he said, "It's a high percentage shot." So we're going to start out with a high percentage prediction here, channeling Dr. J, which is that generative AI is obviously going to have a huge transformational impact on the way we write software, the way we build software. I think that's kind of obvious. And why is that going to happen? That's kind of obvious too. It's because it enables software engineers to reduce some of the cognitive load, to be able to build hopefully better quality systems, faster, better, cheaper, and so on. And I think those are likely to happen. They are happening. I'll talk in just a bit, maybe 10 minutes or so, about my experiences and why I believe that's going to happen and why it's happening. But I think it's also important to remember that not everybody believes this is going to take place. So if you take a look, there's a nice article, an opinion piece by Bertrand Meyer, who's a well-known curmudgeon. He always likes to be the contrarian in the room, and he says, AI does not help programmers. Now, first, I think it's healthy that we have this kind of debate because not everybody can be a zealot or an evangelist. We have to have people who take a reasoned approach. I think he might be a little bit off track. At least my experience doesn't bear out some of the things he's saying, but it's good to have people there who have other points of view. So what are some of the challenges in this space? Well, let's focus first on programming. I find that the large language models of today do a reasonably good job with some aspects of software. We'll talk more about that. But one of the challenges, of course, is they're only as good as the data they're trained on. And if you look around on the internet in GitHub and other places, you find out there's a lot of really bad code out there. And so it's not surprising that one of the challenges we have is how to figure out how to train our models on better vetted code, code that's more robust, and maybe that's probably already taking place at some of the places that are doing the large language models, but we need to do more of that. But it's also important to realize that there's a lot more to software engineering than just programming. And there's lots of other things that are upstream and downstream and throughout the life cycle. And one of the challenges we have is figuring out how these generative AI tools and methods are going to help with those aspects. So the requirements and analysis phases, architecture and design, and so on. And I think we have some inklings of what's happening with some of the newer tools that have just come out recently, like LangChain, where you connect together various other tools, some of which have nothing to do with AI, but they're kind of orchestrated by some of the models in order to weave the pieces together to get the right tool to do the right piece of the puzzle. And various other groups have worked on this for decades. When I was at DARPA many years ago, we had a big project that was looking at tool integration paradigms for model integrated computing. And I think in some ways, this is sort of the next turn the crank in there. As we look further and broader about the software lifecycle, it's also important to realize there's lots of other data out there besides software, just besides the program code. And in particular, there's lots of things like requirement specifications, design documents, test plans, GitHub repositories, chock full of all kinds of other artifacts that could be analyzed. And people are really not that good at trying to keep track of all that stuff. And you can unleash a lot of these tools on these corpi or corpuses, that's a word, in order to be able to figure out better ways to see connections. And we do a lot of the work at the SEI involves going into programs and analyzing large bodies of evidence. Very tedious, very error prone, lots of people with different perspectives, probably can really be well served by better use of these large language models. Something else that's near and dear to my heart is formalizing the discipline of prompt engineering. Now, prompt engineering has gotten a lot of buzz lately. People think that's the job code of the future. But first, what is prompt engineering? There's a couple of ways to think about it. One way to think about prompt engineering is learning to program in natural language as opposed to third and fourth generation languages. So that's one way to think about it. And just like normal programming, traditional programming, there are patterns for how to do effective prompts. And people have begun to codify and document those patterns as a way to do knowledge transfer so others can be more effective at interacting with these large language models and other generative AI techniques. But there's also a lot of people who think this is just a flash in the pan. Very soon, these models are going to get to the point where they don't need to be prompt engineered anymore. They can just figure it out from what you say to them, kind of like the Star Trek computer that you remember. But I think they're really missing the point about what prompt engineering is really about. So prompt engineering is not just about conversational Google searching. It's about trying to be as rigorous in the way that we interact with the LLMs as we are when we build mission and safety critical software. Thinking about version control, configuration management, testing, thinking about evolution. And for those of us who've worked with the different versions of the LLMs over the past 6 months, they keep changing. And if you come up with a way to solve a problem using prompts, and then 2 or 3 months later, everything changes, you've got a lot of trouble on your hands. So thinking through things from a more disciplined engineering perspective is going to be a really important aspect of the future of software engineering and AI engineering. So let's switch gears now and talk a bit about the impact on the engineering of AI-enabled software systems. So first, what does that mean? Well, it basically means systems that contain both traditional, conventional stuff, distributed computing, networking, model integrated computing, mobile cloud computing, all those good things, plus other parts that are, quote, intelligent. And when we start thinking about this, we quickly realize there's a lot more to this space than just the traditional or just the new sucking all the energy out of the room and the air out of the room, generative AI. There's lots of other AI stuff too, robotics, computer vision, and so on. And this is, of course, something else that is talked about in the report. Let's take a look at just a couple of examples of these types of systems, one of which I loosely couple or loosely describe as infotainment systems. And we talk about this quite a bit in the study in the context of engineering societal scale systems, things like all the social media stuff that's taking over the world and causing people to want to ban certain apps in certain parts of the country. So when you think about this, one good example would be YouTube, which has a traditional content delivery system, which is mobile cloud computing and web-based apps for serving video and audio content. That's one piece of it. That's the traditional side, where scale is very important. But there's also the other side that deals with all the AI stuff. So the recommendations, the analysis, captioning, advertising, moderation. Those are a lot of things that are built in using the AI parts. And I think it's pretty clear that that's going to become very much the standard for almost everything that involves web interactions in the very near future, customizing stuff, mostly for advertising purposes, of course. More interesting are mission-critical AI-enabled systems. And so this, of course, would include things like the new Palantir AI platform. If you haven't looked at the video for this, you really got to watch it. I have a link to it in a couple slides coming up, and we'll give the slides out so you can see all the links. It's basically an attempt at trying to apply generative AI models for battle management decision-making processes for the DoD. And it's really quite captivating to watch the video to see kind of what they think they can do with this. And we'll talk more about that when we get to the research challenges. Clearly, AI-enabled software systems have a bunch of characteristics that are not as prevalent in our more traditional systems, especially the safety-critical, mission-critical systems. And my colleague Ipek has written a nice article that talks about a lot of these challenges, and I'm going to paraphrase some of it and add a few things of my own. So one aspect, of course, is non-determinism. Sometimes non-determinism is a good thing. When you're building a chatbot that's trying to emulate human interaction, you don't want it to give back the same robotic answer every time a person asks the same question. If you were to do that in regular life, talking to a person, the person you're asking the same question to and over again will eventually get frustrated and yell at you. Or if you're in a deposition, you'll keep giving the same answer and over again to avoid getting trapped. But that's a good thing in that context. You want things to have some variety. In other contexts, like if you're trying to build some kind of missile defense system on a shipboard platform, you probably don't want it to just be non-deterministic when it's trying to figure out how to readjust resource management assets to confront new threats that have come out of nowhere. Maybe not a good thing. You'll certainly never get it certified by the Weapons Certification Board. There's other issues, of course, related to emergent behavior, which are ways in which complex patterns arise spontaneously from the interactions of simpler elements or simpler system components. This, of course, gives rise to all the wonderful dystopian science fiction movies like Skynet and going back to HAL and so on, where the system is no longer under our control. That's probably where a lot of the people come from who are worried about the end of humanity as we know it. They've watched too many reboots of the Terminator franchise. More seriously, though, is the extreme dependence on data in these systems. In many ways, the quality, the quantity, and the depth of the data determines what kinds of things you can do with these systems. And another key point, which Ipek does a very nice job of making in her paper, is that testing of data has now become as important in many cases as testing of code. We're all very familiar with testing of code. Many of us, myself included, don't have as much experience testing the data, vetting the data, but that's becoming important to avoid the classic garbage in, garbage out scenarios, which are also responsible to some extent for the hallucinations we see with the modern LLMs. And then something else that's very important is designing for explainability and designing for fairness. Good luck if you want to find the place in ChatGPT where it knows that you put "an" in front of a word that starts with a vowel as opposed to "a." Good luck finding that piece of code. It's probably nowhere to be found. Why does this matter? Well, again, if you go back and you watch the Palantir video, which is quite fascinating, one of the things they say they're going to be able to do is they're going to be able to show traceability between the recommendations that they're giving out for the battle management in a modern conflict environment, taking into account things like mission goals, resources, weapon target pairing, evidence, rules of engagement, policies that are in effect, and so on and so forth. Now, when you watch the video, when you first watched it, it wasn't clear whether it was a demo or a prototype. Now they have a little disclaimer at the very beginning that says, this contains forward-looking statements that are not intended to be taken as a real product. But when you watch it, I think you'll be impressed at how realistic it seems like it could be. And it wouldn't be surprising that people would be trying to do this stuff very soon. But this explainability aspect, of course, is a huge limiting factor for systems like this. So what are the challenges? There are many. And they basically involve trying to figure out how to upgrade and augment all the software engineering stuff we've been doing for decades and being able to do a better job of specifying, architecting, designing, analyzing, deploying, sustaining, and so on, these AI-enabled software systems. I was watching The Graduate the other day, the famous Mike Nichols movie, and I figured I had to channel my inner Mr. McGuire, who said to Dustin Hoffman very famously, I'm paraphrasing, I just have two words I want to say to you, assured AI. So if you want to know where the future is, I think maybe the long pole in the tent that's going to make or break this technology, see if it'll go to AI summer versus AI winter, is assured AI. If we can get that thing under some control, and it's really not under control yet, then we have a chance to use these technologies in these more aggressive mission-critical systems. This is particularly important, of course, for the DoD. I've done a lot of work in the DoD over my career. Not everybody else around the world who fields military systems is as concerned as we are about things like minimizing collateral damage, making sure the system is reliable, making sure the system is safe and secure. We spend an enormous amount of money and time trying to assure those properties. Not everybody does. So that puts us at a bit of a disadvantage in some cases because other people don't care. Obviously, one solution here is to continue the ever-present goal of shifting to the left. But that's true for everything. That's not an AI thing. Everybody needs to figure out how to shift left. I think probably more important here is figuring out how to do continuous quality assurance of these platforms at runtime, because that's something that we're not going to be able to test them thoroughly in the lab. It's just not going to be possible. And when you think about what makes it hard to use these advanced technologies, not even AI technologies, but just things from maybe 1980 and beyond, in a lot of military systems, especially safety critical systems, it's very hard because we don't have the testing community yet at the point where they know how to leverage advances and find their way into the certification and authorization programs. This is something else that's covered in the study. It's covered, there's a whole section on the assurance of continuously evolving software systems, which is also going to be very much impacted by advances in AI. Interestingly enough, there's some attempts within the generative AI community to do generative AI to test itself. There's something called AutoGPT, which has this little symbol. If you've ever watched the Marvel comic universe films, I think this looks like the Hydra symbol. So that might be something to think about. But basically, you apply the models to themselves repeatedly and keep trying to find a way to converge. That might work pretty well if you're trying to find ways to generate an English essay or write your PhD dissertation or generate an NSF proposal or something like that with ChatGPT. It's going to cause a lot of problems for these safety-critical real-time and embedded systems, where they're loath to even use processors with more than one core and a cache and stuff like that. You know, they want to use systems from the 1970s. So the last part of my talk, I want to focus on why I'm excited about this. I honestly have not been as excited about technology in I don't even know how long. And I started doing this about the same time most of you probably did, about 6 months ago. And one of the things that's really great about the technology is the barrier to entry is ridiculously low. Why were case tools so slow to get adoption? Because you had to pay a fortune and get lots of licenses to use them to do anything. With stuff like ChatGPT, you could just do it. So I just did it. So I've been applying ChatGPT in my courses at Vanderbilt, and I'll focus on one particular course where we're building essentially mobile cloud computing systems using all kinds of advanced cool stuff on a range of platforms, mobile devices, cloud devices, laptops, and so on. And this particular class, the assignment there is to build a movie recommendation app which has both AI and non-AI components. So it fits in nicely with what we're talking about here. The particular course I'm focusing on is CS891, and it's a mezzanine course. That means it's for both graduates and upper division senior level undergrads. And that's relevant because it avoids a lot of the thorny issues we're dealing with pedagogically, introducing these tools too early into the curriculum before people know what they're doing. And we'll come back to that. So let's talk about some of the things we might do here. And my goal in all this was to become a better teacher. I wanted to use the technology to make me better, make my lectures more interesting, make them more relevant, make the assignments more interesting as well. And one of the things I started with was there's a lot of topics over the years I just have not had time to learn. I've focused in my career on networking and middleware and concurrency and distributed computing, but I never really looked a whole lot at newer forms of data management and database access, which is very important nowadays in modern cloud computing and web-based environments. So first thing I wanted to do is I wanted to introduce that into my class. To do that, I had to understand it enough so I could teach it and I could assess it for my students. So since I didn't have time to go back and get a master's degree in databases, what I did was instead use ChatGPT and began to realize I could program things using natural language prompts, and it would then generate the code that would interface with the database. So that was pretty darn cool. And then what I also wanted to be able to do was tell my students, you're using these abstractions like Springs, a Java persistence architecture, data API. But here's what the queries really look like under the hood. I wanted to tell them that. I said, ChatGPT, what does the query look like for this interface? Boom, there it goes. And those are really easy things to double check to make sure it's giving you the right answer. I also wanted to be able to generate code using techniques I didn't really understand very well yet. But once I had them, I could reverse engineer them and then teach myself and then teach my students. So I learned very quickly that you can use tools like ChatGPT to generate custom SQL queries that go above and beyond the kinds of things you can do with just a simple API. There's things with keywords for simple queries. But if you want to do more sophisticated stuff, good luck trying to dig that out of the documentation you find online. It's very daunting. ChatGPT, boom, generated the code. I also was often reluctant to embrace this stuff because I was like, oh gosh, there's all these imports I've got to bring along. I've got to have build dependencies, all these other things that aren't really the code part. It's the stuff that goes around it, the plumbing. But ChatGPT could generate the imports. It would comment my code. What a wonderful thing. Nobody likes to comment, myself included. But it's important to have good role models for your students, so I could have comments. It would generate the build dependencies and so on. And what's really cool, in the last couple of months, you can now get IDE plugins that will do this stuff for you, so you don't even have to sit there and cut and paste stuff into the ChatGPT window. And there's a lot of really neat tools. Some folks at the SAI are heavily involved with that. It's really exciting. It's still work in progress, but it's just great when it works. Something else that was really useful was I could now take very clever solutions that my advanced students did, where I would spend minutes and hours pondering, what the heck does that code do? And I could simply cut and paste it into ChatGPT, and it would tell me. Because ChatGPT, especially for languages like Java and Python and C++, where it's well-trained, it's really good at code summarization. So it knew what it was doing. And then I could say, aha, I'm going to take that code, and I'm going to generate it in more modern ways. Java's gone through evolutions over the past couple of decades. There's modern ways of doing Java with functional programming. So all I would do is I would take this code, I would say, please generate that using modern Java. Boom, out it comes, works great. In fact, ChatGPT reads the whole manual and understands the whole manual. I often only understand the little piece I want to learn. So it would come up with great solutions I didn't even know existed. And it was very trivial to test them and make sure they worked, because I had the test cases and everything else. We'll talk about that in a second. The other neat thing was once I did this in Java, it was absolutely trivial to generate the same solution in other languages. Languages like Python, piece of cake. It really understands Python. Then I thought, gosh, I'm going to go back to the middle 80s when Bill Shirless was the program manager for the Arcadia program, where I was funded as a grad student. And I wanted to see whether it could generate Ada, because that's what we were doing back in those days. And lo and behold, I haven't written Ada in almost 40 years. And in about 3 seconds, it was generating Ada code for me. Now, I didn't take the time to verify that code, but it probably is pretty correct. But I thought, wow, that's just fantastically amazing. Something else, generating unit tests. Unit tests are really painful. But they're very important to teach the students how to make sure their code has a more higher probability of being correct. Generate unit tests. This is also something that is now integrated into plugins you can get. There's a whole thing called DiffBlue out there that will, quote, automatically generate unit tests for you. Now, they're not perfect, but they're a sign of where things are going very, very quickly. Something else that was useful, I get questions all the time from students, both in my classes and on my online forums that I'm part of, where I'm like, oh gosh, I remember that stuff, but it's going to take me a while to figure it out, and cut and paste the code, say, ChatGPT, please explain this concept, and then generate some examples for me. And boom, there you go. It does it very quickly and often very correctly. This is particularly useful. I have a YouTube channel with about 20,000 plus subscribers, and I post videos of all my courses that I ever do on YouTube. I have 3,000 videos up there. People ask me questions all day long, most of which could be answered by ChatGPT. I try to do my best to keep up with them because I want to encourage them to subscribe and ask questions and participate. And now I just ask the questions to ChatGPT, take a look quickly to make sure it's the right answer. I give them back like 4 or 5 paragraphs of well-crafted prose that give precise answers to their questions. They're like, you're the most helpful professor ever. This is all so-called job security, right? So the point of all this is doing it the old-fashioned way, where I would have taken courses, I would have tried to read stuff online. It would have taken me such a long time, I probably never would have done it. I never would have updated my courses to be modern, to be new. This stuff would take seconds, minutes, hours, a day or so in the worst cases. Quite transformational. So that's why I'm a little bit hesitant to totally embrace Bertrand Meyer's contention that AI does not help programmers. It has seriously helped me be way more productive than I ever could have imagined with very little investment other than being smart enough to know when it's wrong. So let's wrap up here with some discussions about some general strategies for using these types of tools effectively. Now, I'm going to focus a lot on the education part, but I'll try to generalize it a bit. So first thing, we had a modern summit meeting at Vanderbilt recently where we had all kinds of top military people come, people from the service academies, talking about how they're using these large language models or not. Interestingly enough, the Naval Academy banned the use of ChatGPT. Air Force Academy totally embraced the use of ChatGPT. Those of you who know the difference between the services can probably figure out why that was funny. My philosophy is to encourage rather than discourage people to use these technologies. However, it doesn't come without some risks. We have to rethink how we assess stuff. For example, I try now to make my assignments more open-ended because if I just give well-defined specifications, it is so easy to cut and paste those things and get a darn good starting point with the answer like that, which defeats the point of learning. But what I do instead is I make the assignments open-ended, so they have to use ChatGPT to fill in the blanks, which is kind of cool. That's what the real world is becoming. Even more complicated, quizzes and exams. During the pandemic, we moved everything to online quizzes. I love that because I don't have to try to read sloppy handwriting. The problem with that is that now it's too easy for people to cheat. So we have to come up with ways to be clever. So one thing I try to do is I make my questions more contextual. As we discussed in class yesterday, blah, 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 right? Very hard to ChatGPT that one. In fact, that's one of the problems. It also encourages people to come to class. People have gotten spoiled by being the pandemic kids, and they don't want to come to class anymore. So we do this to make sure they come to class. Another thing to do is make your stuff more modern. ChatGPT has a cutoff date of September 2021. If I use technologies that are from beyond that point, they can't look them up online as easily. Now, this is not a long-term solution, but it'll at least get me down for the next couple of years so they upgrade the model. But I think more generally, generative AI is causing us to rethink the way we assess all kinds of things that writing was the way we used to evaluate it. And if you recall the history of music, when recording became popular, certain musicians, particularly jazz musicians, moved to performance because you couldn't hide behind overdubs with performance. The true quality would come out. And I think we're going to move back to that, where more people are forced to do whiteboard stuff in interviews, not just, hand in something that they did themselves. In fact, my poor 16-year-old son, he was taking an English class this semester where they were going to write sonnets. He was so looking forward to writing sonnets. They were doing romantic poets. The teacher decided, no more sonnet writing. All you guys are going to cheat with ChatGPT. It's pointless. So people who really wanted to do stuff manually are now kind of cheated out of a certain aspect of education. Something else that's important, make sure people know the good, the bad, and the ugly of this stuff. So as you all know at this point, these tools are great if they're trained on good data. If you're using a mainstream programming language like Java or Python, you're in luck. If you're using a somewhat esoteric language like Clojure, good luck getting ChatGPT to generate anything useful for you whatsoever. And of course, we all know about hallucinations where it gives crazy answers. If you've ever asked something about yourself, you've won the Turing Award, you've won the Nobel Prize, it's actually very kind of ego boosting. And it also leads to very highly embarrassing outcomes. If you've seen recently, a couple of lawyers submitted briefs where they generated the citations to cases that did not exist. And that the judge got really pissed off, wants to sanction him. Their excuse was, we thought ChatGPT had access to data sources we didn't, and that's where those citations were coming from. Which I thought was a pretty clever excuse, mind you, but you got to be careful here. So the main point here is that these tools are great when they work to supplement the learning process, but not to supplant it. And that's particularly true for beginners. We are still grappling with how we're going to teach the intro courses nowadays, because you can imagine every single introductory programming exercise that we did, the Towers of Hanoi, the 8 Queens problem, those kind of things, instantly solved with ChatGPT perfectly every time in any language you can possibly imagine, right? So really put some pressure on people to figure out how to do this fairly. So let's go ahead and wrap up, and I'd like to have some time for questions and discussion, because I think this is a really interesting topic. So learning to use generative AI tools effectively is a very important step forward if we're going to achieve this vision of humans and AI working together as trustworthy collaborators. Right? It's not the end goal, but it's a great first step. However, even though we had to move our timeline way to the left about when this stuff was going to be happening at all, after our study came out, the trustworthy part's probably the piece that's going to take a while, right? If you're really going to get to the part where you can trust it and not doubt everything that comes out of the model and double check and triple check and quadruple check everything, we're going to have to get further in terms of a lot of advances. And that's what I find myself. When I use ChatGPT, it hallucinates, but I've also quickly learned to know when it's hallucinating. And I don't waste time going down that rat hole anymore. A novice is probably either just going to believe it's correct, or they will waste an enormous amount of time trying to converse with it and coax it to give something sensible. Sometimes prompt engineering can help you, sometimes it can't. Knowing when to give up is a very important skill to learn. So if we play our cards right, we'll be able to get to the point where we can rapidly evolve and generate these systems based on program intent. Why is that? Everybody's going to be a programmer. So one of the things that's most fascinating with using these large language models is we're all programming now. You are always programming these things no matter what you do. Now, some of us will go on further in our careers and learn other more formalized, disciplined, structured ways of programming to computers. But you can think about these LLMs as basically computing platforms, and we're programming them, and they're giving us output. And if you get really good, you get good output. If you're not so good, you get bad output. It's not that much different from writing programs, right? Except using natural language, which opens up many opportunities and challenges down the road. And so we've actually done a whole bunch of papers on this topic, which are actually getting widely cited. It's kind of fun. And then we're also generating art. One of my colleagues is an artist, and he's generating art with Midjourney and DALL-E and so on. Another thing I think that's very important, and I have found this personally in my use of these technologies. When I program now, I am so much more productive because I'm doing the fun stuff and not wrestling with the low-level gobbledygook. The tools are doing the low-level gobbledygook. Low-level gobbledygook is no fun. But if you think about what it takes to be a professional software developer, you spend way too much time with low-level gobbledygook. That's a technical term, by the way. So those are all the things that are like the import statements and the build dependencies and the commenting. And I'll tell you what, ChatGPT is way better than I am at writing comments now. I'm good at checking to see if the comments it writes are good, but it comes up with stuff that I would just never think to do. So very nice, probably has a lot of training on that. Move away from mundane details. What's also fun is to unleash ChatGPT on obscure C code contest winners to see if it can figure out what the actual code does. I've actually tried that. It's kind of fun. So there's still a lot of research and development that's left if we want to get to the point where we can use these tools in a trustworthy way. But there's no time like the present to jump in with at least 1 foot, maybe not both feet, but 1 foot, and just try it, see if it works. Sometimes it will, sometimes it won't. A lot of times it won't, but I think we'll see very quickly it'll get better. And my final thought here is the following. We've talked for decades now about the digital divide, which historically was people with access to the internet and computing and those who didn't. I think we're about to have the digital chasm, where there will be people who are very savvy using these types of tools and are 1,000 times or more productive than people who don't know how to use them. And that's going to cause all kinds of problems. In fact, there's a whole bunch of discussions about what's going to happen where, the age-old quote, AI will not take your job, but a person who knows how to use AI is likely to take your job or use AI better than you. And I think that's really what we have to be aware of. And it's incumbent upon us, people who are the leaders in this field, to get ahead of the curve so we're in a better position to help others be successful in making that transition across this chasm. So that is the end of my talk, and let's talk about questions.